Okay, so we've daisy chained the ground wires to all of our switches in the different groups. So we've got the lower group, we've got the mid group, and the upper group, but with a couple caveats. The first one is that these thumpers, I prefer to have the switch on a connector. The reason is that this whole unit is meant to be pulled out as one piece, and it doesn't make sense to have to break out your soldering iron just to take this out. You can see that this one already has a connector on it because it was pulled from a different game, so that's convenient. But I will go over separately how we're going to connect to this, because we don't want to daisy chain in the connector, meaning we don't want to put two wires into the same crimp of a connector. So we're going to do something different to make sure that we only have one wire coming into this, and we have to do that for all three of these units. All right, the other caveat is that the spinner has, there's one over here, this one's going to have a similar wire. The spinner has a ground and power that goes to the LED, but this is going to need a dropping resistor to basically limit the current that goes to the emitter. And then we'll also have a ground and a signal coming out of this. So we're going to need a little interface board for these two spinner optos, and we'll go over that later. Last caveat is that the drop target bank is going to have a connector as well, because again, it's a complete unit and we want to be able to pull it in and out without having to desolder. The difference is that connector, we've dedicated an entire bank of 8 to this drop target bank, so it'll only need just a single connector coming from here to here, and then everything else will be contained inside the drop target. All right, the next step is we want to wire in the signal for the switches. We have the ground, we need the signal. On vintage machines, they had unique color codes for every wire. So there was at least 10 different colors of wire, and then each wire had the option for like one of 9 different colors of stripes on the wire, and sometimes even 2 stripes on the wire. So on a vintage game, every single wire color code was unique. For homebrew, we don't really have the option, the resources to have hundreds of different colors of wires. But what I do like to do is on my switch matrix that I use on other games, I usually split it up into banks of colors that are reserved for the columns and the rows, and then at a minimum I can, when I'm troubleshooting, I can reduce it down to one of a couple options that it might be. All that to say is that I'm going to, when I do these switches, your options are basically to either maybe do them all white and then put labels on them, that's valid. A lot of people do that in industry. The other option is I'm going to go with what I have here, what I normally use for my switch matrix, since it's already in banks of 8. I'm going to use this color code for that. Okay, so on this driver board, the pins are numbered from 0 on this side to 7, and then 2 grounds here. And this is considered the switch bank number 1, 2, 3, 4, and they're keyed slightly differently. You can see this one's keyed on pin number 5, this one's on number 4, 3, and 2. So we're going to start with this one, and going from 0 to 7, which means what I like to do is, if we're doing this group here, I've labeled it in our little diagram here. We're starting, again, we're reserving a pin for this flipper switch. This is just a test switch, but we'll have a connector here for the flipper, and then it'll be out lane return sling on the right. Remember, this is flipped over, so this is the right side, and then sling, return, out lane on the left, and then flipper on the left. Alright, so we're going to be coming from here through here, and I'm going to use one of our wire ladders. We're going to want it right about here, and that way any wires that are coming into this board from this side will come in through here, and we can see that this will work pretty well if it just comes in this way on this lower one and then connects to here. So we're going to screw this down using our same screw, and there's an opening. You should be able to get your screwdriver into that gap. Alright, and I like 2 screws for this as well. Okay. Alright, that's nice and secure, and now we'll do our wire. Alright, similar process for our other wiring. In this case, we're going to start with this one, out lane right, which is green color. So we'll take our green wire and give ourselves a service loop, and then we want to basically run it along this path, kind of following the other existing wires. We're going to want to run it into the wire ladder right about here, and then when we get to this part, we're going to imagine having a service loop like this at the connector, and then the IDC will be right here. And then let's give ourselves a little bit extra, maybe an inch or 2 extra. And then once all the wires are there, we're going to trim them, put them in the IDC connector, and then we'll be set. Alright, let's strip this. Alright, same thing, tin both wire ends. Alright, and we'd already tinned our switch. Let that cool. Alright, and then same process, we'll just sort of temporarily tape our wires where they belong on with the other wires in the harness. We're going to come back and clean these up with some cable clamps. Alright, that's going to go about there. Alright, once I get to here, we're just going to leave this hanging, and then once the bundle is complete for all 8 of these, we'll trim them all the same length and then put our connector on. Alright, the next wire, the return lane, is blue. Same thing. We follow the existing wires, bring it over to here, and then this time we only have to just basically make it the same length as the green one. Alright, and then the same process, we just strip this, tin it, connect it to here. I'm going to do this for all of these, and then we'll come back when it's time to put the connector on. Okay, now we're looking at it from the other side. This is the right sling, sorry, left sling, but it's on the right when it's flipped. So this is the left sling, and notice that a couple things. One is that it's an orange wire for signal, but I've run it the same orange wire back over here to the other one. So now these two are in parallel, so triggering either of these switches triggers the sling. Then also notice that I'm taking a shortcut through here. You could have equally come around here and then this would be one bundle. I've decided we're going to go this way. It is going to be a little tight in here because this is where all of the coils come, but I think we can sneak these under over to here, and then this will become one bundle. All right, I'm going to do the same with all the other bundles, and only after we get everything, all the wiring locked down, that's when we'll put the connectors on, because as we go through this and start putting cable clamps, there's going to be additional slack where we need to either give or take a little bit of length, and that's why we cut this extra long, because when we get to the end, this is where we're going to be cutting it even. So doing it, locking down the cable clamps first and then putting the connector on, gives us like a little bit of extra wiggle room. All right, we're nearing the end of all of our low voltage wiring for our switches and our LEDs. And there's one thing we don't want to miss before we sort of button all this up is we want to wire in our connections from our expansion board, that is the LED driver, to the actual LED boards. And these wires are going to be, well, the first one's going to be here, but they're going to go all the way through here. And we're going to want to run them along some of the same routes. So we want to get those in place before we tie everything down. Okay, what I'm going to use for this is this 4-pin Molex crimp connector with a 1/10 inch spacing. And they give you a little diagram here where it says port GCDV. So it's ground, clock, data, and voltage. We only use ground, voltage, and data on this. We don't use the clock. So the pins we're going to put on here are going to be, the arrows pointing to pin 1. So it's going to be pin 1 is voltage, 2 is data, skip 3, and then pin 4 is ground. Okay, I've got my first little pigtail here. This one's going to be going from this end. And remember, I switched this so this to be the start, and then this is going to be right about there. And so we put our pins into our header. Voltage, which is pink, is pin 1, and there's also an arrow on the header that's pin 1. Oops, sorry, from this way. Push that in until it clicks. Data is number 2, and then ground is 4. Okay, and then this will sit on here like this. There's an arrow on the connector, on the header there, so it'll sit like that. And then we'll solder this. We gave ourselves a little bit of a service loop, and then we'll solder this to this here. Okay, we're going to do the same thing for this one, and then also this one here. These two plus this one, same thing. Okay, so we got these connections for the LEDs in, and it kind of looks like a mess here with all the blue tape, but now it's where we're going to start the cleanup and start tying down this harness to the playfield. And we're going to start at this section here, the farthest point, and then we're going to work our way back towards the driver. And the reason is that at each step of the way, as we move from back to here, there's going to be a little bit of slack in the harness that we're going to want to work out. And so as we start to tighten things up, that slack is going to be either more or less per wire. And by the time we get to this, a little wire bundle, it's going to have all different lengths. And then we'll cut it to be all equal and then put our connector on. If we did it the other way, if we did it from here backwards to where it's already connected, then we'd end up with a lot of uneven lengths wires, and it wouldn't be as clean. All right, so that's the next step. We're going to start tying this down from the farthest away back to the driver. Okay, I'm now on the other side. This is our farthest point. All right, our primary tools are going to be cable ties, and we have a variety of sizes, so we can select the right size based on the size of our wire bundle, which is going to increase as we get farther and farther around. So at the starting point, the other tool is going to be zip ties. So at a starting point here, you notice we have at least 3 wires coming off of this switch. So I almost always put a wire tie directly off the bundle coming off of a switch. And the same would be true for this one. We put a wire tie on this bundle, like so. And then in this case, let's pull this out. If we start removing our tape, you see here this connector is a placeholder for our spinner. We're going to have a spinner interface board that's going to plug into that. All right. So in this case, we'd also put some wire ties here, going out that way, and a wire tie here. Okay, it's nice and tight. And then we're going to put a clamp here. And it looks like, I guess a 3/16. Looks like a 3/16 would be okay. All right, and then we just screw this down to the back of the playfield. All right, and for this wire here, we want to put another wire tie. Okay. All right, and then to clean it up, we have some flush cutters. And by flush cutters, I mean the back of this is completely flush. So instead of having the blade like a dike coming at an angle, it's flat and then an angle. And the idea is that when we cut this, we're not left with any kind of sharp edge when we cut the end off the wire tie. Okay, so we clean these all up. All right, and that's what it should look like at each stage. All right, let's go to the next section. We'll pull our blue tape up, get rid of all this. All right, now it's a strategy. I like to try to put clamps in areas where the wires are relatively straight. So right about here is where a clamp would be. And we can use wire ties in this section here. So we're going to put a clamp here. That's a little too big. Okay. All right, that's the right size. Put that clamp there. And then we'll use wire ties to bundle these, to get them tighter. And then you can see, like, here's an example where there's a little bit of slack. We want to pull the slack out, and we're pulling the slack out back towards our connector. And we'll put another tie here. Okay. We'll probably put another tie right here. Okay. Yeah, and then clean this up. Again, the flush cutters make sure that you don't have any sharp edges coming off of this edge where you cut. All right, so we're going to basically follow that same strategy as we work our way around. Put cable clamps in areas where it's straight, and then usually wire tie to hold the bundle tight around curves. We're going to work our way backwards, increasing the bundle as we go this way towards our connector at the driver board. All right, here's another strategy example. So as we come around this curve, we're sort of pulling the slack out, and we have these two wires branching off. And so where it branches, we put a wire tie on the branch coming off, and then also a wire tie on each side of this branch. All right, so this locks it in like this. So we would not put a clamp at this curve, but we would put wire ties when this branch is off. And again, you see some slack here. We're going to start to work this slack out backwards this way. Okay, so we started here. We've gotten to this point, our wire bundle. We're at a point here where this has branched off, so the thumpers have a branch going this way. So we're going to take the same strategy and start on this side, work our way backwards until we get to this junction, and then continue from here on. So we want to start at the farthest point back to the driver. All right, so now we're going to, once we got to this junction here, we're going to go back and go from this part back to here. Okay, so we got this branch all bundled up to where these two meet, and now we're going to work our way back down here, and this should be the final bundle. Okay, so we've got all the switches bundled up, and we've got kind of like this rat's nest right here. We're going to deal with that in a minute, but now that we got that, we're also going to do similar to the what we did with the switches. We're going to do for the lighting. We've got a few lighting things we have to take care of, and the GI that goes around the edge. So we're going to clean that up first, and then we're going to come back and we're going to show you how to put the connectors onto this to then plug into the driver board. Okay, so we got a majority of the wire management done for the low voltage stuff, meaning the switches and the LED lighting. And just to summarize the guidance, the idea is that we want to put zip ties around cable bundles. When there's a branch, we'll have a zip tie on either side of that branch just to keep everything tight. And then we're going to use the cable clamps in areas that are primarily straight, and also use these cable clamps to keep the wire bundles off of critical areas where we don't want them touching, like the switches and the mechs. All right, so that's the general guidance there. The next step is going to be handling this bundle of wires and putting a connector on there. Okay, I probably should have mentioned this earlier. Because we don't have an unlimited number of color codes, we're using just 4 colors to wire in our switches, which means some of these get repeated. And when you get to the time where you need to bundle these up, we should have been putting labels on the end of these wires to let us know which bank they belong in. So this first bank of 8, this will be labeled 1 and 2. The second bank will be 3, 4, and the third bank will be 5 and 6. All right, so you're going to want to put a little tag on here on the wire to let us know which one of those it is. All right, now we're ready to put our connectors on. And one thing to note here is that the way these connectors are set up, these 4 banks are the switch inputs. This is the first one, and the way it's set up is we have switch 1, 2, 3, 4, then a key, then 5, 6, 7, 8, and then 2 grounds. So it's an 11-pin connector for this one. These are all 11-pin, but when you get to the second connector, you'll notice that the key is on a different pin. So if we ended, if you actually started this being 0 and that being 7, this channel would start with 8, 9, 10, then a key, then 11, and then 12, 13, 14, 15, and then 2 grounds. And the same as you go to the third and the fourth bank. Okay, since we're going to do this first one first, we've already separated our bundle, so we have what we're calling 1 and 2 for our colored wires. We're going to do the first 4 wires, which will all be numbered 1. And if we pick those out, it's going to be these 4 here. It's going to be these 4 wires. And we do notice that the shortest one is this red one, but we're actually going to cut it a little bit shorter, because what we need is essentially to come in here, go to this bank, and then give ourselves a little bit of a service loop, and it's going to be coming from the top down, the way this connector works. So we're going to cut these first set of wires right about here. We want them all the same length, so we'll pull these tight. We're going to cut it right about there. Right about here. Cut them all the same length. All right, now we look at our schematic. Pin 1 is orange, and we go orange, green, blue, red. And then we look at our connector. Pin 1 is here. And so that's on this side. And the way this works is we want the wires coming in. I'm going to put this down on a flat surface. I want this orange wire coming in to that pin right there, just over it. And then we use our tool. You can see that when you push down this tool, it's going to sit in there, but we're going to push it on top of that wire. Just very carefully. You don't want to push too hard right away. You want to sort of get it seated. All right, trying to give you a better view here. I get this wire seated in there, and then use this tool to push down. Okay. All right. Now that's nice and secure. And then we go to the second one, which is green. Do the same thing. Spacing's a little tight here. Start gently at first because you don't want to put too much force on it, and then you can go harder as it goes in. Okay. All right, so we're going to do the same for the blue and the red, and that'll be our 4. And then we're going to skip a spot and then do the next 4. All right, so we have these 4 in here. Now we're going to cut our second group of 4 to the same length. So right about here. All right, and then remember, for this first one, it's 4 and then a key. So we're going to skip that spot, skip a spot, and then go to the next one, which would be pin 6. All right. Okay. All right. Then we can continue from there again. So green, blue, red, and then we'll do the ground. Okay, so we got those 4. Now we're doing our ground, which we had also labeled 1 for bank 1. we're going to cut it to the same length. All right, and I'm going to put it, we could put it in either one of those two remaining locations, but I'm going to put it in the very next one to keep it tight. Okay, so now we can put it onto our header here, and this is a friction lock, and you notice that the connector has a little bit of a ramp, so it's going to be a tight fit, but we want to push that on all the way like that. And then when we route these wires, the wires come straight up this way, so we'll give it a little bit of a loop, and then we'll tighten that, and then we'll tighten this down to our wire ladder. Okay, all right, now we're going to do the same for our other groups for this, and this, and just remember that the key changes on each connector. Okay, so we did our other two bundles of 8 wires, so now we have 3 here. This fourth one is going to be reserved for the drop target bank, which will have its own dedicated connection there. All right, now that we've got that, I'm going to skip solenoids for now. Normally I would do solenoids second, but for logistics reasons, because we're going to take this to the show in June, we're going to move on to connecting our boards with the network cables and then to our playfield interface board. That's going to be next. All right, so we're not going to wire in our high voltage power yet, but for demonstration purposes, I want to start running our low voltage 12 volt power. This board needs 12 volts, as well as our control signals that would come from our neuron to this interface board and then to each of these driver boards here. All right, so that's what we're going to do next. One thing to note here is that the communication protocol for the driver boards is a closed loop network connection, and so there's going to be an in and an out for each node board, and that means this is a nano, but the neuron will have a similar connection here. That means that the driver boards are going to need an in and then an out to the next driver board, and then out back to the playfield interface, and then that goes out to the neuron. Okay, so now the trick is, what I like to do is I like to color code these connections. There are labels on them, but you can imagine, like, if this is buried in your cabinet underneath the playfield, you may not always be able to actually see that label, and so I like to have a color code just for this connector, and then I will also color code the cable. So this is the network cable we're going to use, and as long as you put yellow on one end, blue on the other end, then you will always get it correct. Just match the yellow with the yellow, and then this goes to the next one, the output, or sorry, the input on the next one. All right, so color coding, I think, helps making sure you avoid like any of these control wiring issues. All right, now the caveat here is that in this new system, we have, not only do we have the network buses here, but we also have expansion bus. The expansion bus is not a loop. The expansion bus is all in parallel. So all these connections are in parallel, and they're going to go to this expansion board, and these connections themselves are also in parallel. So in that scenario, instead of using blue or yellow tape, I'm going to use red tape on these connections, and then similarly, instead of doing yellow and blue, I'll put red and red on both ends of this cable. Okay, so we've put our color codes on our interface board, and we're using blue for in, yellow for out, and similarly we've put our color codes on our driver boards, yellow out, blue in. And then also on our expansion board. In this case, these are in parallel, so they're just red in the same way that these are in parallel. So these are all just red. Now on this interface board, even though this is blue and this is yellow, the way this works is that these are just connected straight across and straight across. And the idea is that because this is a playfield meant for playfield disconnect, you're going to have 3 cables coming in, hopefully coded blue, yellow, and red. They'll go in here, and then your other cables coded yellow and blue will come in here. So the in from one goes into the out from the other, which then becomes the in to the next one. So for instance, this cable here is coded yellow. When it goes into the next board, it's going to be blue on this end. All right. And then similarly, we've also color coded our cables for the expansion bus, colored them red, but they're not going to be polarity sensitive. All right, so we'll just go red to red. All right, again, because this is a playfield disconnect, and we'll have, like I said, we'll have 3 cables coming in here that'll be blue, yellow, and red, but we're going to want to come in from the back side. So we're going to want this as close as possible as we can to the back, and then temporarily what I'm going to do, because I want to power this up separate from having in the cabinet, I'm going to put a little terminal block here, and we'll just have a little pigtail. We'll bring in power, and then we'll just jumper it over to this power input. But we still want this to be as close as possible to here. So we're going to mount this down here. I'll mount this terminal block separate, but it's not going to be part of the actual game. And then we'll start mounting our wire ladders in different strategic locations that will run, because we'll want to run to this board, and then the control lines, the network control lines over to here, and then loop back to this one, and then the 804, and then all the way back. The output of this needs to come all the way back to go in to here, which would then become the output to the game, back to the neuron. All right, like other boards, I'm okay to drill it straight in here, but you may want to put a standoff to keep it up off the playfield. The key is you don't want to drill this down or screw it down too tight, because there's stuff, a little bit of things on the backside, just enough that if you were to try to tighten it down all the way, you'd end up cracking the board. All right, so don't do it too tightly. I'm also putting it, you notice I'm trying to stay clear of this area here, because this is where some of your playfield mounting hardware is going to go when you put it into the cabinet. So you don't want anything too close to the edge of the board. All right, and we'll do 4 screws for this. And if we end up creating a standoff for this, I'll try to link it in the description. All right, I'm going to do the same for these others, and then I'll probably even mount these wire ladders where I know that we're going to want them.